look at length contraction, and this is an experiment which is a thought experiment. You imagine that you have a ruler, and at one end of the ruler you have a signal to flash light to this end of the ruler where you have a mirror. So this is a mirror. And because this will happen in the same space, the signal will go to the mirror and come back, and let's say this is now length L prime. We can say light traveling will take 2L, that is the distance, over the time, change in time t, will give you the speed. And we know that we can also say it the other way around, that 2L over c, the speed of light, will give us change in time t prime. That is measured in the same frame of reference as the events being light leaving the point, going to the mirror and coming back. So two events have happened in the same space at the same point, and therefore we measure proper time. Let us now imagine that we have the same ruler and the same mirror, but this time the flash is again done from this point to the mirror, but the mirror and the ruler are now moving at a velocity v. So we say, let's say we don't know what the person outside this frame of reference is going to measure. So we say, let's say he will measure L, which is not proper length. He will measure L, and we know he will find the signal is going to find when the light, the mirror has moved some distance, and that distance is velocity times time 1. This is forward signal. This is forward signal. So the total distance covered, d, is equal to L plus v minus, v t1. And we know that d is also equal to c times change in time t1. So since this d is the same, we equate the two and we say L plus v change in time t1 must be equal to c change in time t1. And therefore we can say L is equal to c change in time t1 subtract v change in time t1, and therefore we say change in time t1 into c subtract v, and therefore change in time t1 is equal to L over c subtract v. Let us now look at return. That is forward. We now look at return. That signal is now coming back. The same ruler, but the signal is now coming back. When it comes back, the ruler will have advanced some distance v times change in time t2. So the ruler will have advanced. Since this was L, then on return, that signal will find the ruler has advanced, and it will now be L subtract v times change in time t2. And that distance is the same as c times change in time t2. Again, we go through the same ritual like the other side, and we can actually say change in time t2 is now equal to L over c plus v. Total time taken to and fro, forward and return, is therefore going to be total time t, change in t, must be change in t1 plus change in t2, which is the same as L over c plus v plus L over c minus v, which we can say is LCM. LCM is c plus v into c minus v, and this will go there c minus v times L, so L into c minus v, and this one will go there c plus v, so L times c plus v, and therefore you have to open that bracket, the brackets up, you get c LC minus LV plus LC plus LV over, this is actually a difference of 2 squares, so it is c squared minus v squared. And the top one is actually, this is going to cancel out with that, so you have 2LC over c squared minus v squared. You now have that equation as the total time t, and you can say, let us divide the numerator and the denominator by c squared, so that we have change in time t is equal to 2LC over c squared over c squared over c squared minus v squared over c squared, and this leads us to 2L over c into 1 subtract v squared over c squared. And from our time dilation formula or equation which we solved on this on another video here, we know that there is a relationship between change in time of a traveling, of a moving frame of reference in relation to a stationary frame of reference. Change in t is equal to change in t prime over, this is from time dilation, over 1 subtract v squared over c squared square root. So from this relationship, this is change in t, this is also change in t, this must then be equal to this. Therefore, 2L over c into 1 subtract v squared over c squared must be equal to change in t prime over root of 1 minus v squared over c squared. But we know from this equation up here that change in t is equal to 2L prime over c. Therefore, this here must also be equal to this change in t alone must be equal to this one. Therefore, 2L prime over c over root of 1 minus v squared over c squared. This is just the same as 2L prime divide by root of 1 minus v squared over c squared over 1, which is the same as 2L over c times 1 over root of 1 minus v squared over c squared. Having seen that, we then know that this one here, this is L prime to L prime. So we can now say that what we have here is in fact the same as this. So 2L over c into 1 minus v squared over c squared must be equal to 2L prime over c into root of 1 minus v squared over c squared. Multiply both sides by c over 2 and you have L over 1 minus, this is a bracket, 1 minus v squared over c squared is equal to L prime over root of 1 minus v squared over c squared. Cross multiply and you have, this implies, if you cross multiply, this implies L prime times 1 minus v squared over c squared is equal to L times the root of 1 minus v squared over c squared. Divide both sides by root of root of 1 minus v squared over c squared, and you remain with the right hand side as L is equal to, this one will go here, square root times divide by this on both sides, that's what I mean. Then this becomes L prime, of course it is L prime 1 in v squared over c squared over root of 1 minus v squared over c squared, which gives you root L prime times root of 1 minus v squared over c squared is equal to L. Now this fraction is smaller than 1. It's a fraction smaller than 1. And this is proper length. So this fraction smaller than 1 multiplied by a number will lead us to conclude that this length is shorter than proper length. So L is shorter than proper length. So that is proof that moving length shortens.